Regulators. Regulators! Mount up!
Well, good morning, good afternoon, or good evening, depending on what time of day it is that you're watching this video. In this lesson here, we're going to go over the law of cosines. But before we do that and we go over the law of cosines, let's read this quote here by Abraham Lincoln. The best way to predict your future is to create it. Hey, you guys, if you're thinking you're going to be highly successful when you grow up and you're going to be manager of your own company or the owner of your own business, if you're making that prediction right now, you're creating it. You're getting education. So that's the best way to predict your future, is to create it. So Abraham, thanks for that. All right, here's the law of cosines. Okay, it's got 6 different things here, but in reality, we only have to remember one, right? It says right here, let's just look at this one here. A squared equals b squared plus c squared minus 2bc times the cosine of a. Okay, it's real similar to the Pythagorean theorem. Like right here, c squared equals a squared plus b squared, right? If we had a right triangle and a and b are the legs and c is the hypotenuse, then that's true. But if it's not a right triangle, the law of cosines is telling us is we can take any side and square it. That's going to equal the sum of the other two sides squared minus twice the product of the other two sides times the cosine of the angle in between them, or opposite the side we put by itself. All right, let's maybe look at this with a picture. All right, I'll just do this generic equilateral looking triangle here. Okay, and let's say this is angle A, this is angle B, this is angle C. So this is side A, this is side B, this is side C. I'm going to pick any side here. Right, I'm going to move this up so I'm not seeing the formulas. Let's say I pick side B, right, and I want to set up the law of cosines. Law of cosines tells me b squared should equal a squared plus c squared. Right, it's just like I'm doing the Pythagorean theorem. This side squared equals the sum of these two sides squared. But since it's not a right triangle, then I subtract twice the product of a and c, right, the two sides that I squared and added, times the cosine of the angle in between them, which is the angle opposite b, times the cosine of b. All right, and that's this version of the formula right there. Whichever side I pick, it's going to be the same way. Right, and then all they did over here for the alternative form is they solved for cosine. So they took the a squared over here and got b squared plus c squared minus a squared, took the negative 2bc cosine of a to the other side, then divided by 2bc to get the alternate form. But if we can just remember this, then we can always get all these others by solving this for something. Okay, so let's give this a shot. Let's see how this works. The triangle ABC, angle B is 133 degrees, side A is 12, and side C is 15. All right, so I'm going to draw just a generic equilateral looking triangle. All right, obviously now I'm going to call this right here angle B. This is 133 degrees. Obviously this isn't drawn to scale. All right, angle B should really be like this if it's 133. It's going to be an obtuse angle. But I'm not worried about drawing it for scale. I'm going to label it. Right? I don't want to spend a lot of time drawing it to scale. If I had to, I would, but we don't really have to, as long as we label it. So there's angle B. Now, they don't tell us side B. Side B would be opposite that. They do tell us A is 12. So if that's side A, then this is angle A. Okay, and side C is 15. So that means this is angle C. All right, because whenever we solve one of these, the first thing we want to look for is a side angle pair. And we don't. We don't have a side angle pair, so we can't use the law of sines. Right? The law of sines is a little bit more straightforward. That's one we want to try to use if we can. So since I can't use the law of sines, then I'm going to go to the law of cosines. Since they give me this angle right here, that's the only angle I have, I'm going to find this side first. So the law of cosine says I can take this side squared it should equal the sum of the other two sides squared, then minus twice the product of the other two sides, times the cosine of the angle in between them. So times the cosine of 133 degrees, right, which is the angle opposite B. Because I could do the rest of this right here in my calculator, right? If you can remember the law of cosines, this is pretty nice because now you can do the rest in your calculator. See, I'm going to go back to the main menu. I'm going to check. I'm in degree mode. That's what I want. All right, so I'm going to take the square root. Since b squared equals this, I'll take the square root of this. The square root of 12 squared plus 15 squared. So the square root of 12 squared plus 15 squared. Then I subtract the product of those two sides. So 2 times 12 times 15 times the cosine of the angle in between, which was 133. Boom, there's side B right there. About 24.790 if I round to 3 decimal places. 24.790 units. I'll take a picture of that. Help me remember it. Whoop. Let's move this over here. So side B is 24.790. Okay, now, you guys, we've got an angle side pair. I could use the law of sines to find the other two sides. Or I could use the law of cosines. Or, since I'm learning and I'm practicing right now, why not do both? Hey, let's say I want to find angle A. All right. Then what I would do if I'm going to use the law of cosines is I'd put side A by itself. So that's 12 squared. That's going to equal the sum of the other two sides squared. So 15 squared plus 24.79 squared. Minus twice the product of those two sides times the cosine of the angle in between. So times the cosine of A if I'm trying to find angle A. So now here's where I want to work backwards to try to solve this for cosine of A. So what I would actually do well, I'm going to do it because I'm working this one out. I'm going to take this, and the first thing I'm going to do is I'm going to take 12 squared, and I'm going to subtract 15 squared. Then I'm going to subtract 24.79 squared. Okay, that's what negative 2 times 15 times 24.79 times the cosine of A would equal. So then what I'm going to do is I'm going to divide that answer by negative 2 times 15 times 24.79. 24.79. So there's what cosine of A would equal. So then I'll do inverse cosine of that answer. And there's angle A. 20 point, let's see, I'll go ahead and copy this whole thing too, so I can look at it here. So I just figured out that angle A would be 20 point, let's say just go to 1 decimal point here, 20 point, I'll go 2 decimal points, 20.73 degrees. Okay, now you guys, the nice thing about using cosine is you don't have to check for 2 different answers like you do with sine. Because if you remember, all trig functions are positive first quadrant, sine the second, tangent the third, cosine the fourth. That means we could have another triangle right here, and this angle is 20.73 degrees. And then the other angle that would have a cosine equal to this would be 360 minus that, or about 339.27. Right? That's way too big for a triangle. So when you use the law of cosines, you don't have to check possibility of there being a second triangle, right? There is no ambiguity there. Okay, now, you guys, let's see if we use the law of sines to find side angle A. Right, once we found side B, we had an angle side pair. Right, we had 24.79 and the sine of 133. So I'm going to put 24.79 over, that was B, so over the sine of 133. Okay, then it's going to equal, if I want to find angle A, I'll put 12 over the sine of A. So I can put 12 over the sine of angle A. Right, so to find angle A, I cross multiply and divide, and I'm going to wind up with 12 times the sine of 133. Whoops. And then I divide that by 24.79. That's what the sine of A should be. So then if I do inverse sine of that answer, I get 20.73. Look at that, you guys. They call that deja vu all over again. And now what I'd have to do also, if we were doing this strictly with the law of sines, I would also have to check what's 180 minus that answer. So the angle could also be 159.27. But that angle wouldn't fit in this triangle with 133, so it's not possible. So this would be a case where we use the law of sines, there's only one triangle. Okay, now if we've got our two angles, right, angle B they told us was 133. We just figured 8 is 20.73. So if I do 180 minus 20.73, actually I just had that up there, I should have left it. Then I subtract 133 from that. There's my angle C, 26.27. So angle C is 26.27 degrees. Now if we do a little mental checks here, side B should be the biggest side because it's opposite the biggest angle. Angle C should be bigger than angle A because 15 is bigger than 12, and it was. I feel good about my answers. Okay. The law of cosines. Right? Best way to learn it is to do it. So let's try another one. Okay, you guys, this might be a great time right now. Pause the video, try to do this, then start the video again and see if you got it right. All right, the way I'm going to do this, the way I do all of these, I like to just draw a generic equilateral looking triangle. All right, try to stay consistent. So there's my triangle. Let's see. They don't tell me any angles, so maybe I'll call this A, B, C. They're telling me side A is 16, so that's opposite angle A. Side B is 20, and side C is 32. All right, so automatically right now, I'm thinking to myself, when I do this, angle C is going to be the biggest angle because it's opposite the biggest side. Side A or angle A is going to be the smallest angle. Now I'm going to go about trying to find them. Maybe I'll find angle A first. Since A is across from 16, then I would make the 16 squared be the side by itself. That should equal 32 squared plus 20 squared. Right, and then minus 2 times 32 times 20 times the cosine of angle A. And you guys, while I'm at it here, before I start typing my calculator, I'll go through and find all of them. Say I want to find angle B, then I would put the 20 on the side and square it, and that would equal 32 squared plus 16 squared minus 2 times 32 times 16 times the cosine of angle B. You guys notice how it's always the two sides that you square and add together are the two you multiply together and multiply by -2 and take the cosine of the angle in between them. If I want to find angle C, then I'll put 32 by itself. So 32 squared should equal 20 squared plus 16 squared minus 2 times 20 times 16 times the cosine of C. Okay. So I've got all my angles, I got all my stuff set up. Now I can just type things in the calculator and figure this out. All right, so on this, I'm going to see if I can do all this just straight in the calculator. Okay, so to work this out, I'm going to do 16 squared, and then I'm going to subtract 32 squared, then I'm going to subtract 20 squared. Whoops, almost a sabotage. Okay, so it's like I'm taking the 32 over here, 32 squared over becomes negative, 20 becomes negative. I'll do that, then I'll divide that by -2 times 32 times 20. That's what the cosine of angle A should be. All right, so then I'll do inverse cosine of that answer. And angle A should be 24.147 or 24.15 degrees if I go 2 decimal places. Maybe angles will go 2 decimal places, sides will go 3 decimal places. All right, now, because I'm going to see if I can do it all in one step for angle B. So what I'm going to do here is in parentheses, I'm going to do 20 squared. Oh, actually, this will be 2 steps, but still. I'm going to do 20 squared minus 32 squared minus 16 squared. And then I'm going to divide that by -2 times 32 times 16. And I needed that to be in parentheses. All right, there's what cosine of angle B should be. So then I'll do inverse cosine of that answer. And B is going to be 96.28. All right, guys, I'm glad I took a picture of the calculator here because as I'm moving it over, I noticed something. 20 squared minus 32 did not get squared. It's a sabotage situation right there. So let's do this again. Let's try this again. Let's clear this. We'll go up here. There we go. I can just come over here. That needed to be squared. That's what the cosine of angle B should be. So then if I do inverse cosine of that answer, 30.75 degrees. All right, so there's my angle A, there's my angle B. Now let's get angle C. To do C, I'm going to do 32 squared. Then I'm going to subtract 20 squared and subtract 16 squared. So minus 20 squared minus 16 squared. And I'm going to divide that by -2 times 20 times 16. And guys, this calculator's trying to mess me up. There we go. Here's what the cosine of C should be. So then I'll do inverse cosine of that answer. I get 125.099, so 125.1 degrees for angle C. So you guys look at that. Law of cosines all the way. They gave me 3 sides. I used law of cosines to find all 3 angles. All right, we got, let's see, I'll write it in black here. We got angle A is 24.15 degrees. Angle B is 30.75 degrees. And angle C turned out to be 125.10 degrees. All right, we did it with the law of cosines the whole way. Now, guys, once we found, maybe just look at it here and for practice and while we're learning, once we found angle A, then we would have had a side angle pair. Okay, so let's say I wanted to go and find angle B. Maybe I'll do it right. See, I'll move these things down. And once I found angle A, then I had an angle side pair. And I could put 16 over the sine of angle A, which was 24.15 degrees. Right? Then that should equal, let's see, I'll go ahead and find B first. Let's see, C was 32. Okay. If I want to find angle B, then side B was 20, so I put 20 over the sine of B. Right, so I cross multiply and divide, and the sine of B should equal 20 times the sine of 24.15 degrees over 16. So if I want to find angle B, I would do inverse sine. Then I'm going to put 20 times sine of 24.15. So 20 times the sine of 24.15. All right, and then I put that over 16. So if that's what the sine of angle A should be, I do inverse sine to find angle A. And look at that. Or angle B, excuse me, right? We're trying to find angle B. Look at that. We get 30.75, just like we got here. Okay, but because if we did that, we would have the ambiguous case also where we would have to do 180 minus that, and we could have a second triangle. But what's nice about the law of cosines is there is no ambiguity. When we found angle B to be 30.75 degrees, there's not a possible second angle for B, because that wouldn't give us, we wouldn't have a triangle, because that angle would be bigger than 180. Okay. All right, let's try another one. This time we get an angle and two sides. So once again, you guys, I always suggest just start out, draw a generic triangle. Just an equilateral triangle. Let's see, let's label, let's call this C right here. 28 degrees, 43 minutes. That's side C. So, or angle C. So this is side C. Maybe you call this angle A, so this is side A. This is angle B, so this is side B. All right, again, we don't have an angle pair match, but we know an angle and two sides that it is in between. So we use the law of cosines to find side C to start with. So C squared should be 9 squared plus 6 squared minus 2 times 9 times 6 times the cosine of 28 degrees, 43 minutes. Right? It's always the side you square and put by itself is going to equal the other two sides, the sum of the other two sides squared, minus twice the product of the other two sides times the cosine of the angle. Okay. So once we get that set up, we can do the rest in the calculator right here. Right? This is what C squared equals, so I'm going to take the square root of 9 squared plus 6 squared, and then minus 2 times 9 times 6 times the cosine of 28. And to get to degrees, I go option, I go over, angle, F4, 28 degrees, 43 minutes. There's side C, 4.7205. So we're going 3 decimal places, 4.721. C is 4.721. Okay, now that I've got an angle side pair, I could use the law of sines to find my other two angles if I want. So we could use the law of sines to find the other two angles. We might get the ambiguous case. We use the law of cosines. Let's go ahead in this instance, let's go ahead and use the law of sines. Okay, because now there's not as much ambiguity because we know what C is. I'm going to write it over here. C has to be 4.721. If I look at my sides, C is the smallest, so angle C has to be the smallest angle. Right? 9's the largest, so angle B has to be the largest angle. So I think maybe I'll find angle B first. Okay, so to find angle B, I'm going to put side B by itself. So 9 squared, it's going to equal the sum of the other two sides squared. So 6 squared plus 4.721 squared. Then minus 2 times 6. Move it down a little bit. 2 times 6 times 4.721 times the cosine of, let's see, 9 is across from B, so times the cosine of B. Okay, so we're going to do like on that last problem. We're going to work backwards here. So I'm going to take 9 squared, and I'm going to subtract 6 squared. I'm going to subtract 4.721 squared. Then I'm going to divide that by negative 2 times 6 times 4.721. All right, you guys ever realize what I just did here? I said I was going to use the law of sines. I'm using the law of cosines. So let's go ahead and finish it here, and then we'll check with the law of sines. So there's what the cosine of B should be. So then I'm going to do inverse cosine of that answer. And there's angle B, 113. So let's write this in. Well, I'll take a picture of this too. There's my angle B. Angle B turns out to be 113. Well, you know what? You guys, since they give this in degrees and minutes, let's give our answer in degrees and minutes. Let's stick with what they have. So what's nice about these calculators is I've got my answer there. F5 right here converts it to degrees and minutes. So the answer is 113 degrees. We'd round up to 25 minutes. Okay, now, if we'd used the law of sines to find angle B, right? Our side angle pair would be 4.721 over the sine of 28 degrees, 43 minutes, right? And then I'm trying to find B, that would equal 9 over the sine of B. So the sine of B would equal 9 times the sine of 28 degrees, 43 minutes, over 4.721. So on our calculator, since that's what the sine of B equals, we would do inverse sine, because we're trying to find the angle. And we do 9 times 28 degrees, 43 minutes, and we would divide that by 4.721. Nine times, oh, look at that, you guys. That's really bad. I'm pretty sure I hit sine. Maybe the calculator's trying to sabotage me, but 9 sine of 28 degrees, 43 minutes divided by 4.721. Okay, there, you guys look at that. We get a different angle B. But remember what we said when we did this. B had to be the largest angle. If B is 66 and C is 28, that adds to 94. That means angle A would be 180 minus 94, be like 96 something. It would be the biggest angle, and it can't be. So we also have to take that and subtract it. Whoops, take 180 minus what we just got for angle B. Right? So B, look at that, 113, put it in degrees, minutes, seconds. 113 degrees. In this case, we get 39 seconds. It's all depending, it's little discrepancy because we rounded off, right? We rounded off things to use our answers. If we would have used the exact answers, we wouldn't have this. So it'd probably be better to use the exact answers. Like when we went through and found C here, I should have stored that and used that stored value. Okay. But you guys, there's an example. This shows you here. If we go back, right, when you use the law of sines, there's ambiguity. There's this answer, and there's also 180 minus this answer. So that would be the two possible answers for angle B if we use the law of sines. And then when we find angle A, right, if we used 66 for B, angle A would have to be the 113, and A can't be bigger than B. So that's how we know this one's right. Okay, now we know two angles. To find the third angle, we can just subtract them from 180. Right, so I'll do 180 minus, we were given 28 degrees, what was it, 43 minutes. 28 degrees, 43 minutes. Then minus, we figured out B is 113 degrees, 25 minutes. So angle A turns out to be, whoops, put that back, convert it. Angle A turns out to be 37 degrees, 52 minutes. So angle A, I already forgot that. It's 37 degrees, 52 minutes. 37 degrees, 52 minutes. Angle A is 37 degrees, 52 minutes. Right? And we knew angle A had to be bigger than angle C because side A was bigger than C. Okay, so there's a nice example of how the law of cosines makes it so we don't have to worry about a second triangle. All right, let's give this a shot right here. Let's try a word problem. All right, so let's see here. The pitcher's mound on a women's softball field is 43 feet from home plate. The distance between the bases is 60 feet as shown in the figure. So I've got the figure covered up because I want us to draw the pitcher. Then they tell us pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? Well, let's see. And I'm picturing, well, let's try a baseball or softball diamond. It looks something like this. Whoa, went too far over that way. Something like that. Then like that. It says the pitcher's mound is 43 feet from home plate. So, and it's not halfway between home and second. So let's say maybe the pitcher's mound is right there. Come down here. This is 43 feet. And the bases, distance between the bases is 60 feet. So this is 60, this is 60, this is 60, this is 60. How far is the pitcher's mound from first base? So here's first base, so we want to know how far is that. Okay. Now we know this is not a right angle, but these are all right angles right here. That's a right angle, that's a right angle. Here's a right angle, that's a right angle. Okay. I don't know if that's going to help us. Let's see, we want to find this distance, so let's call that D. Well, let's see here. We do know this is 43. We know this is 60. we knew an angle, if we knew this angle right here, we could use the law of cosines to find D. So now it's about trying to figure out these angles in here. So let's think about these angles. How could we go about finding those angles? Well, if these are right angles, these are 90 degrees, then this is a right angle. The pictures mound is straight up here. So this bisects this right angle right here. So that tells me this angle right here has to be 45 degrees. Same thing with this other one. So now you guys look at this. We've got a side angle pair, right? We could go through and find the other sides, but we also know the two sides that the angle's included with. We use the law of cosines to find D. D squared is going to be 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. And before I work that out, let's check to see if our little sketch matches the figure they gave us. Hey, look at that. So I should have had the pictures mound up here a little bit more, but we're close enough, right? It worked. They said this was 45 because these are right angles, so this pictures mound straight from perpendicular here from home plate comes straight down in, so it bisects this angle. All right. So now all we got to do is plug this in our calculator. Right, so to find D, I would take the square root of 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45. So look at that. D is about the distance from the pitcher's mound to home to first base is about 42.43 feet. So the distance is 42.43 feet. Or if we want to know that in feet and inches, then we could always take this. We know it's 42 feet. Subtract the 42 off of that. It'd be that decimal of a foot. So since there's 12 inches in a foot, multiply that by 12. And we'd say about 42 feet, 5 inches. All right. So you guys, there's some great examples of the law of cosines. How we can use those to find missing things along with the law of sines. Okay. Now, in this section also, we're going to talk about Heron's formula. And Heron's formula is another way of finding the area of a triangle. But in this case, we find the area of the triangle if we know all three sides. So they say the area of the triangle is the square root of s times s minus a times s minus b times s minus c, where s is the sum of the sides divided by 2. So if you add up all the sides divided by 2, that's the s. Then if you take the square root of that times the difference between that and every side, you get the area of the triangle. So let's give that a shot. Right? Here's a triangle. We've got sides 43, 52, 72. So maybe I'll just sketch that. I sketch this triangle. Let's say this side's 43, this side's 53, this side's 72. All right, so if I find the s is going to be 43 plus 53 plus 72. All of that, whoop, grab the eraser there. All of that divided by 2. So let's see, if we do that, we're going to get, let's see, 96, 166, 168. 168 over 2, we're going to get 84. All right, so that's telling us the area then is going to be the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. Let's see how difficult this would be. Let's see if we could do this without a calculator. We get the square root of 84, and then times 84 minus 43 is 41, times 84 minus 53 is 31, 84 minus 72 is 12. Now this would be a pain to multiply out, but we could do some things here like 12. Let's tackle this 12 for a minute. 12 is 4 times 3. So I could take the square root of 4, which is 2, and leave the 3 in there. 31 is a prime number. So is 41. 84 I could think of as 4 times 21, and the square root of 4 would be 2. I'd still have 21 in there. So we get 4 times the square root. Oh, we can multiply this out. Let's see, 41 times 21. Or actually, you know what, guys? This would be even easier. Now we've got this way. I've got 3 times 21 is 3 times 7. Then times 31 times 41. So 3 times 3 is 9. Square root of 3 is 3. So now out here I've got 12. If I do 41 times 31, I get 1, 4, 3, 12. 1,271. Then I got to multiply that by 7. So let's see, we get 7, 49, carry 4, be 14, be 18, carry 1, 7, 8. 12 times the square root of 8,897. Okay. Now, let's check this with the calculator. All right, double check, make sure I got my S right. I do 43 plus 53 plus 72. I'll divide that by 2. Sure enough, I get 84. So then I'll take the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. 1,131.88692. Let's compare that to 12 times the square root of 8897. Look at that, you guys. Deja vu all over again. Right there. Right, you wouldn't be asked to do one with this big of numbers without a calculator, but we just showed we could. So that means if you've got one with nicer numbers, you should easily be able to do it. All right, so that right there is approximately 1,131.887. Right, the exact answer is more preferable to the decimal approximation. Right, but if it doesn't say, it's okay to give either one. Okay. Now, Heron's formula is nice, you guys. Look at that. We never had to find an angle. Now, we could have, right, maybe just here to finish this off, what if I did do this? Right, this would be more work, but what if I forgot Heron's formula? And what if I wanted to find this angle right here? Well, let's call this angle X. Right, I could do 72 squared. So just give me practice with the law of cosine. 72 squared would equal 43 squared plus 53 squared minus 2 times 43 times 53 times the cosine of angle X. So if I figure out angle X here, I could do 72 squared minus 43 squared minus 53 squared, then divide that by negative 2 times 43 times 53. That's what the cosine, whoops, guys, that was bad. I gotta have parentheses around all this stuff that's going to be in the denominator, or else what it does is just divides by negative 2 and multiplies by all the other stuff. I missed my parenthesis there. 72 squared minus 43 squared minus 53 squared divided by 3 times 53. I don't like how this is turning out. 72 squared minus 43 squared minus 53 squared. There's another mistake. I need to parenthesis here. There's multiple sabotage situations. There you go. That's much nicer. Because I knew there was something wrong with all those others because I was getting a big number. If I'm trying to find the cosine of an angle, that ratio has to be in between -1 and 1. So now I've got that. So I can do inverse cosine of the answer, right? That would be angle X right there. So maybe I'll store that. I'm going to store it in A right here. Okay, now I do know that the area of a triangle we got in the previous lesson is 1/2 the product of two sides. So 1/2 times 43 times 53 times the sine of the angle in between. So watch this. I'll take 0.5 and I'm going to multiply it by 43, multiply that by 53, then multiply that by the sine of that angle that I stored in A. Oh, you guys tell me if that number right there doesn't look familiar. Right? Tell me if that isn't deja vu all over again. 1,131.887. Look at that. So, because even if we forget Heron's formula, we could use the law of cosines to find an angle, and then use our other formula for the area of a triangle. Right? So there's multiple ways to do these problems. Okay? Key is practice this stuff. Work at it. Do the homework. Do the test review. Do any extra problems you can do. And always remember, endeavor to persevere. Thank you for watching this video, and I hope it helps.